Hello, my name is Richard Austin. I represent IBM Storage Defender in Australia and New Zealand. Richard Austin in Australia, Maverick often in New Zealand. Today we're talking about enhancing data resiliency with IBM Storage Protect Hybrid Cloud, so Storage Protect and IBM Cloud Object Storage. And this is in direct relation to the critical infrastructure resiliency that is being adopted across Australia and other countries today. Organisations spend a lot of time and money to ensure recovery from disaster. Planning, preparing and testing is often done. Yet a disaster is actually quite a low probability. Organisations now realise that what is more likely is a cyber incident, but the same preparation and planning is often not done. Data protection and cybersecurity must work together for the foundation capabilities in order to provide full data resilience. New regulations and requirements from insurance companies are now in play across the globe to ensure resiliency measures are in place for a broad range of organisations. The Australian government established the Critical Infrastructure Centre in January 2017 to safeguard Australia's critical infrastructure from the increasing complex national security risks of sabotage, espionage and other threats. The centre's establishment was necessary because the risk from foreign interference, including espionage, pre-positioning for sabotage, and other things, is not well understood by government or business and therefore not factored into risk management practices. The centre works across all 8 critical infrastructure centres: banking and finance, government, communications, energy, food and grocery, health, transport and water. The centre helps states and territory governments, regulators and owners and operators to better understand and manage the risk or build resilience. So that's what's happening in Australia. But how can we improve data resilience when we're talking about specifically the Storage Protect family? And that can be part of Storage Protect alone or Storage Protect as part of the Defender portfolio. So what sorts of immutability or worm or air gap does Storage Protect offer today? Well, we support worm, read once, read many. So once the data is written, it can't be changed. And that sounds quite a resilient solution. We've got AWS S3 object up. So again, it's time-based, but once the object is written, it can't be changed until a time parameter is reached. And this capability extends to IBM Cloud Object Storage Vaults as well, which can be deployed both on-premise and air-gapped to the public cloud. Storage Protect for data retention supports worm, storage scale, NetApp snaplogs, and a few other content addressable storage types. Storage Protect Plus, which we're not covering today, also supports IBM Cloud Object Storage Retention Vaults and worm via Storage Protect. And of course, we've got capabilities around flash copy, safeguarded copy, copy data management to protect our primary storage repositories. Now, specifically what I'm going to cover in part 1 of the demo today is we're going to be linking in what we know as IBM Cloud Object Storage. And this object store is unified. It can be deployed both on-prem or in the cloud or through a combination as well. So it's a true hybrid cloud solution. And because of the erasure coding that's built into the platform, we can recover data if we lose any single site, if we're in a 3-site configuration, which means this is highly available data. Once more, it's supported with IBM Storage Protect for Cloud, IBM Storage Protect Plus, and of course, IBM Defender Data Protect. Today, as highlighted in blue, we're covering IBM Storage Protect with IBM Cloud Object Storage. So what's the context and why are we here? So you're probably familiar with what you need to do in order to protect around a file that's gone missing or gone rogue. You're probably aware of what you need to do and has often tested disaster recovery. But have you architected the environment for cyber recovery, for infrastructure regulations? And how do you achieve things like zero trust or object lock for data copies? They're the kind of things that we're showing today. So as part of what I'm showing today, I'm going to do a demo. Yes, I said that right. I'm going to do a demo. I'm going to cover Storage Protect container pools on site. I'm going to show data that's contained in those dedupe and encrypted container pools. I'm going to show movement rules, and then I'm going to show the data transferred to secure storage pools in IBM Public Cloud. As you can see, I'm logged into IBM Cloud. You can see at the top in the browser cloud.ibm.com, and I've logged on as Richard Austin. We can see that we have a bucket called Defender Vault Oz in our configuration. And now we're going to see something similar in our Storage Protect Operations Center. So if I click on Get Started, and then if I select the storage pools, we can see that there's a number of containers. DCP1 is on-prem, and there's also a number of object off-prem cloud storage pools that we're connected to. If we look in Cloud Connections, we have two active connections, IBM Cloud and, for this demonstration, IBM Cloud Vault. And we can see the bucket name is Defender Vault Oz. We can also see we have a storage rule defined. Within the rule, there are two subroles, and today we're looking at the subrole for Server 1 CL, Secure Vault. We can see here that we have previously tiered data from our source pool on-prem to our IBM Public Cloud. And what we're going to do now is we're going to rerun the tiering process. So we're going to run a storage rule that should tier any inactive data from the existing container pool that's deployed on-premise to our IBM Public Cloud. We can see a number of completed tasks, and we can see that the tier storage pool has completed. However, we can also see that actually no data has been tiered, and that's because there is no inactive data to tier. We've established that there's no inactive data on the Storage Protect server to migrate to IBM Public Cloud. So what we're going to do is we're going to create some inactive data by forcing the Protect server, or the Protect client in this case, to back up data that is already backed up. So we're going to click Always Backup. This goes against the incremental efficient methodology of Storage Protect. But for the purpose of the demonstration, we do need additional copies of the data on the server so that we can only transfer, or only data that's eligible for transfer is moved to IBM Public Cloud. In the interest of time, I've accelerated the process, but as you can see, it was a rather fast backup because not a lot of files. And we can see through the security notifications that some unusual activity has happened. Yes, I've just performed a manual backup. Into storage rules again and select Run Now. Source pool DCP1, directory container pool 1. And this time, hopefully, there's going to be some data that's going to be moved to IBM Public Cloud. So I click on the server and I go into the details. So we can see here in completed tasks, there's a storage pool worker and the summary as well. So we can quite clearly see that data has been moved from on-premise storage pool to our cloud object storage pool. Logging into the Defender Vault bucket, specifically looking at the objects, with a quick refresh, you can see that the screen is refreshing and is updating. We can see now there are multiple different objects that exist in IBM Cloud Object Storage. To recap, we've covered some of the why and some of the how with Storage Protect. You can enhance your cyber and critical infrastructure resiliency by storing data in IBM Cloud Object Storage. We've seen data backed up on site, we've seen data move, and we've seen data exist in IBM Public Cloud. Did you know IBM offers a free cyber resiliency assessment for you as an organization to help you build an effective cyber resiliency plan. Reach out to myself or your local IBM representative to learn more. As a senior representative in IBM, I'd like to thank you for making it this far. I'd like to thank you for considering IBM technology. And I'd like to thank you for listening to not just this part, but parts 2 and 3, which will hopefully assist you in building a resilient data architecture.